You'll need out your note page, so you'll need a textbook. Once you're on page 364, looking up that information there. Here we go. Okay, so can I have your attention back up here? So, what's the greatest number of horizontal asymptotes in a rational function? Dustin? 1. Why? Sid?
So otherwise it's not an asymptote, because an asymptote is a line. And if you had more than one, it would be two separate lines.
Okay. We could have two separate lines. We're going to see today that you could have more than one vertical asymptote. There's a specific reason, though, why we can only have one horizontal. What do you think, Elizabeth?
Oh, it's because if you have more than one horizontal asymptote, then it won't actually be a function. Won't pass the vertical line test thing.
Okay, it wouldn't pass the vertical line test thing. Yeah, that's true. It wouldn't be a function. Okay, well let's take a look and think that if we have, say, y equals x, or y equals 1 over x. All right, let's pick some values for x. Let's say we put in, I don't know, let's put in 1/2. Let's put in a 2. Okay, we get y equals 1/2. All right, let's put in, say, 4. Y equals 1/4. Let's put in, I don't know, put in 100 or 1,000. What are we getting very close to? 0. We're getting very close to 0. So if you think of a rational function as being in the form of y equals 1 over x, right? And then we started adding stuff to x down here, our h value, right? You're subtracting. Y equals x minus h on the bottom. Y equals 1 over x minus h. And then we started adding stuff out here in the k. Whatever we get down here, no matter what x is, eventually, I mean, we could get 1 over, I don't know, 1 million. We're very close to 0 at that point, right? Everyone with me?
Yes.
Okay? And if we add something to it, let's say k, let's just maybe add a value out here. Let's say we're plus 2, our k value is 2. Now, rather than being really close to 0, we're really close to 2. So your asymptotes now move to 2. Okay? You're never going to have multiple asymptotes because you're only going to get a single number for y each time. Whereas when we have x and we're factoring, we can get multiple x values. You can get, say, if we have y equals, in fact, let's use
X plus 3 over x, the quantity of x minus 4 times the quantity of x plus 3.
Let's try that one. Okay? Now, we just ignore the top for a minute and just look at the bottom. We know our asymptotes appear where this can't be 0, right? What values can we get on the bottom that make that 0?
Plus minus 2.
Yeah, plus minus 2, right? We factor it. Difference of 2 perfect squares there, x plus 2, x minus 2. Okay, and then on the top, we have that x minus 2. Okay, well, what we're going to see today is, well, here, neither of these can be 0. So that means when x equals negative 2, that makes that 0, which would give us 0 on the bottom. When x equals positive 2, that makes that 0 on the bottom. Okay, so you have two different discontinuities here. Now, I used the word asymptote earlier, but really only one of these is an asymptote. The other one's what we call a hole. Okay, but they're both called discontinuities. Okay, so remember that word from yesterday, discontinuities. Make sure I actually spell it right today. Okay, this one right here, this one's called a removable discontinuity. Make sure I stay on the screen there. Removable discontinuity. All right. Dude, I spelled it wrong again. There it is. All right. Removable discontinuity. Tell your neighbor why that one's removable. We haven't talked about this yet. Let's see if we can figure it out.
Because you make the top 0 as well.
So why is that a removable discontinuity? Andrew?
Because everything multiplied by 0 is equal to 0, so either one of those is 0, the whole thing is 0.
Okay, very true. That's why it's a discontinuity. Why is it removable? Why are we can take it out of there? Brooks?
Because it would also make the top value 0.
It would also make the top value 0. What happens here?
This becomes 0.
They cancel. Okay, we removed it. When we cancel those, what's on top? Yeah, 1, not 0, just a 1. And on the bottom, what are we left with? X plus 2. So our new function, after we remove that, we have y equals 1 over x plus 2. That graph and this graph, so that one and this one, will look extremely similar if you put them on a calculator. Like everything will look the same with the exception of one point, and that's this point right here. In fact, if you were to graph this one and zoom into this point on the x-axis as close as you could, you would see your graph, it would be doing this. I don't know if it goes this way, but you would have just like this little gap in the graph. That thing we call a
Hole.
hole.
Ooh.
It's a discontinuity. It's where your graph doesn't exist. If you look at your table and you graph this one, you'll see an error at positive 2. Versus in this one, if you were to just graph this one without telling your calculator that you had this to begin with, if you were to graph this one, you wouldn't see that hole. Okay? But in this one, you're going to see the hole. Okay, so we're going to see that today. I want you guys to take a look at number 11 on the example side of your worksheet. Okay? Number 11 looks just like that. It doesn't have all that other cool stuff on there. Okay? I want you to go ahead and go through and get a graph set up for that right now. So here we go. We've already factored this, right? This is the one I just put up on the board. We factored it. We said that the denominator, the first step, becomes x plus 2, x minus 2. All right, and then we were able to take that piece out. Right? We call that our hole, and our hole exists at
X equals 2.
at x equals 2. Right? So off on the side of your table, now I know yours isn't set up just like this, but you always want to list your asymptotes and your hole, your discontinuity here. Okay? So this whole function reduces to y equals 1 over x plus 2. We've reduced it. So now as we're doing our table, and we want to put those pieces, these plug values in, let's plug them in. We can plug them into this one or to this one, but it's probably easier if we plug them into that. In fact, I'm going to rewrite it here so it's easier to see. It's probably easier if we plug it into that. Okay? Where's our asymptote at?
-2. X equals -2.
Good. X asymptote's at x equals -2. Tell your neighbor where the y asymptote is. Okay, volunteer? Sophie? 0. In fact, what's our k value?
0.
0. All right. Remember, that's our asymptote. Okay, so when we build our table here, we're going to put in our asymptote first. All right? And I want to be able to get 3 points on either side of it. Now, in your tables, I don't think have I given you 3 on each side?
Yeah.
Okay, good. So we're going to go ahead and put our -2 right here. We're not going to worry about the hole right now. And we know that that's going to give us an undefined for y. Now, you have that extra column in there where you can show work if you want to. But then we're going to pick 3 values on either side. So say I pick 1 here, maybe -1, maybe 0, and then let's pick a real big value off our graph, 10. Okay, and over here, let's pick, say like -3.
Yeah.
About here? Okay. How about like maybe -7? Maybe one a little further away. Okay, how about Negative 10, okay. You don't have to pick ones that are right next to it. You could pick ones that are right next to it. It's up to you. But I want you to go ahead and fill out your table using those values. Okay, so we put these values in for x into our equation. What do we get for negative 10?
Negative 1/8.
Negative 1/8. How about negative 7? Negative 1/5. How about negative 3?
Negative 1.
Oh, that's nice. How about negative 1?
1.
That's nice too. How about 0?
1/2.
1/2. What do we call this point?
Or y-intercept.
Good. The y-intercept. Remember, label those special points. This is your vertical asymptote. Okay. How about 10? 112? Okay. So let's get it graphed now. All right. Well, I'm going to put Marina's graph up here. So there's her table. There's her graph. Notice she's got the x asymptote at negative 2, the whole at 2, and the y asymptote at 0. And so we've got our graph here. Now the one key piece that we need to put that hole in now. Okay? And so Marina, I'm going to write on yours. Okay? So when we go to x equals 2, we're going to go all over here to x equals 2. And where we get to that point, what we're going to do is we're just going to erase the graph a little. We're just going to put a little hole right there. Okay? And that's going to show that discontinuity. Well done. Since no questions on number 11, let's move on to number 12. Everyone give that one a go. I want you to fill out your asymptotes, your hole, your table, and try to graph it. Ready, go. So to get us started on this, I've talked to a few of you, and I see a lot of you canceling the x's, which are great. This is already factored down here. That makes this negative 1 up here, right? And what makes x equal 0?
1.
When you set x equal to 0, what makes it 0?
0.
0. That's your hole.
Whoa.
Your hole's at x equals 0. Okay? Whenever you have a value out here, you're not adding or subtracting anything to x. It's just 0. Okay? X minus 1 equals 0 when? At 1. So that's your x asymptote. What's your h value? Yeah, it's 0. Hey, gigglies. Holy cow. All right, there we go. Hey, building our table. What goes here?
1.
Good, 1. What's this? Undefined. Okay, what are we going to use here? Someone give me one of their values. 2. Negative 2? 2? How about here?
5.
5. Here?
10.
10. Here? 0. What is that called?
Y-intercept.
Y-intercept. Okay, this is our vertical asymptote. Okay, what's this? Anyone pick it?
Negative 2.
Negative 2. How about here?
10.
Negative 10. All right, there we go. Get our table filled out. Hey, real quick, Brooks just asked a good question. Can you cancel out the negative 1 on top and negative 1 on the bottom?
Yes.
No, this is implied parentheses down here. You have to cancel that whole quantity. That's going to come up quite a bit in this chapter, so that's a great question. It has to be this. Okay? Remember, we can put them into the reduced one. It's easier to put it into this one rather than this one. Either one would work. What do we have for negative 10?
1 over 11.
1 over 11. How about here? 1/3. How about 0? 1. How about 2? Negative 1. How about 5? And 10? Negative 1, 9. Okay. Okay, graph them. So I've got mine graphed. Now remember, our hole's at x equals 0. So we've got to erase this point right here where x equals 0, and we've got to put a circle there. That's our hole. Okay? Any questions?
Where's the hole?
Hole's right there.
Oh, yeah.
Questions?
Not anymore.
All right, very good.